Okay, you can share the screen.
Okay. Yes.
Your name is Katerina, right?
Yes, Katerina.
All right, good. So we're having 30. So before going for 30, can you tell me what is the standard way of writing the equation of a line?
Just a regular line.
Yes.
Y equals mx plus b.
Correct. This is the standard way of writing it. And what about the, sorry, this is the slope intercept way. Slope intercept way of writing it. But what about if you're given the point x1, y1, and you are given the slope m, how can you write the equation with x1, y1, and m?
Oh, learn this. Okay, hold on. It's like
Mhm.
y minus y1
Yes.
equals m times x2 minus x1.
No, it's y minus y1, not y1 minus y2 or y2 minus y1. It's y minus y1 equals m times x minus x1. Correct. Yes.
Okay.
So y minus y1 equals m times x minus x1. And x1, y1 is given there, maybe 2, 3, or 5, 6, whatever that is. And m is also given. So you'll be putting those numbers here, and it'll be getting the equation in the point slope form. This is called point slope form.
Yes.
And the third form of writing the equation of a line is standard form. Standard form is
ax plus by
yes equals
c.
correct. So this is the standard form of writing an equation of a line. So we're having 3 forms of writing the line. In the same way, when you're having what you can say x to the second power, when you're having the equation containing x to the second power, because line will always be produced when we'll be having x to the first power, 1, 1, 1, 1, 1, 1. So whenever you'll be having power as 1, then the line will be created. But when you'll be having the power as 2 on x, then parabola will be created.
Oh, okay.
Okay, so that means if you want to write the simplest parabola in this world, then that'll be simply y equals x squared. Simple. For example, if you want to calculate the simplest line, which is containing a slope, that'll be y equals x.
Yes.
This is a line. But in the same way, if you want to calculate the simplest parabola, it'll be y equals x squared. So this will make us when you'll be graphing it, you'll be getting a parabola.
Okay.
Right now, if you want to have some standard equation of the parabola, then that is y equals standard equation.
Oh, y equals is it the same as the standard ax squared plus by
bx plus c is like this. Ax squared plus bx plus c. This is the standard form of writing the parabola. Okay, so y equals ax squared plus bx plus c. This ABC is very, very important, because that's going to give you so many things, so much information available in this ABC. But first of all, let's try to see the representations. This is the standard form. There's one more way of representing an equation of parabola in factored form. And the factored form is y equals x minus some alpha times x minus some beta. This alpha and beta are these points where they are cutting the x-axis.
Okay.
So this is the factor. You can write it somewhere, the factored form of writing a parabola, where alpha and beta are the you can say that a and b, not a problem, but ab should not be confused with this ab.
Yes.
That's why I have written alpha beta. You can write somewhere something else also. X minus p times x minus q, pq. anything, but those 2 points are actually the x-intercepts of the parabola. So,
Oh.
yes. So this is the factored form of writing a parabola. The third form of writing a parabola is called the vertex form. Vertex form is going to give you the equation containing the coordinates of the vertex. Vertex means the minimum of parabola or the maximum of parabola. If the parabola is like a cup, then this minimum value may be like -15 or -1, 15 or something. And if it's maximum value, you know, this x1, y1 will be the vertex.
Yes.
Minimum or maximum of the parabola is called the vertex. So how can you write the vertex form? It is, if you will write the coordinates of the vertex as h comma k, okay, then the equation, the general form of the vertex form, the general vertex form of the parabola will be y equals x minus h whole squared. That a here, this a here can be written everywhere. A is here also, a is here also, a is here also. X minus h whole squared plus k. You can write it somewhere. This is the vertex form of the parabola. So 3 forms: standard form, factored form, vertex form. Okay. Now I want to go a little bit deeper here because this is a very, very important thing, and it comes, you know, in the SAT many times with different forms, you know, different equations, different things. So today what I'll be doing, I'll be giving you a little bit information about the factored form and this standard form. And the vertex form we can do a little bit later, maybe. No, we have to do it here also, because here only, because we're having the question in this containing the vertex form. Okay, so I'll be removing everything. Now, I'll be writing this again. Okay, I wanna share the screen for a moment.
Okay. I can stop my share.
Yep. Okay. I want to show you something for the parabola thing here. So let's go to the GeoGebra. So I told you the simplest parabola is y equals x squared, right?
Yes.
So I'll be writing y equals x squared. I got a parabola, see? So now the number which was in front of it, you remember, y equals ax squared plus bx plus c. You're having a in front of x squared.
Yes.
I have put in 1 for a. That's why I got y equals x squared, right?
Yes. And then
all the things I got, I have put in 0. B is 0, C is 0. Right? C, as it was, as there was a y-intercept in the line, in the same way, you're having the y-intercept here as C in the parabola. Since we have put that equal to 0, that's why this is cutting the y-axis at 0.
Yes.
Now, I want to increase this A. I want to put it 2. See what will happen to the parabola, whether it'll be contracted or expanded. What happened to this?
It expanded.
Wait, okay, I'll be
no, wait. The opposite. Oh, no, contracted.
Contractions going on. So when you increase A, the parabola will get more and more contracted, right? Now let us put it back to 1. Okay, this is the parabola. Now I want to decrease it by, you know, some number, like for example, this is 1, I'll put it 0.1. So I've decreased it. So what has happened?
Oh, it expanded.
Right. So 1 is a standard, you know, parabola. When you increase, you know, when you increase A is greater than 1, it will start contracting. And if A is less than 1, up to 0, it'll start expanding.
Yes. Okay.
Okay, so first thing, the effect of A on the parabola. Did you got that?
Yes.
One more thing A is going to tell you. If A is a positive number, till now we have done all the positives, right?
Yes, you've done all the positive.
If A is a positive number, then the parabola will be like a cup opening upwards. Isn't it?
Yes.
Now, if A is negative, for example, you're having negative 1x squared, it'll be a mountain opening downwards.
Oh, okay.
So what's happening with the A? The sign A is positive or A is negative. What's happening with that?
If it's positive, it's up. If it's negative, it's down.
Yeah, if it's positive, it's cup. If it's negative, it's mountain. You can remember it
Yes.
like this.
Okay.
If it's positive, it's cup. If it's negative, it's mountain. Right?
Positive cup, negative mountain.
Positive cup, negative mountain. Right. So positive cup. Okay, I'll be putting positive again back. Positive cup here. A is positive. It's like a cup. Then what is the vertex? Is it minimum or maximum?
It's the minimum.
Minimum. That means when A is positive, the vertex will be minimum. Right or wrong?
Right.
If you want to write it somewhere, you can write it also these few points, because every point which I'm saying is a question, is a question of the SAT.
Yeah.
So if A is positive, the vertex is minimum. Now, if A is negative,
it's the maximum.
It's the maximum. Correct. Now, what's happening? See, negative 2x squared, I'll be putting it negative 9x squared. It's again contracting, right?
Yes.
So expansion occurs only when you're having 0 to 1 or 0 to negative 1.
Oh, okay.
And then more than negative 1, like lesser than negative 1, you'll be again contracting.
Okay.
And greater than 1, you'll be again expanding. Oh, sorry, contracting. And this portion is expansion.
Got it.
Okay till now? Everything clear till now?
Yes.
Okay, because, so many things together. Okay, coming back to the x square, smallest, easiest parabola. Now, if I want to shift this parabola to the right or to the left or to the up or to the down, what I will do, this is again a question in the SAT.
Okay.
So if I want to shift it up or down, that means I am changing the y, isn't it? Up or down. Like I'm increasing or decreasing the y-intercept. See what I will do. If I want to increase, if I want to change it, if I want to make it up, if I want to shift it up 3 units, I'll be simply adding 3 to it. Adding 3 to it. See, it has shifted 3 units up. If I want to shift it 5 units down, I'll be subtracting 5 to it. That's it. It has shifted down 5 units.
Got it.
So y-intercept is -5 now. Yes. Now I have introduced the y-intercept also. It was before, it was 0. Now, if I will be adding 5, it will be shifting up 5 units. If I'll be subtracting 5, it'll be going down 5 units, right?
That's the -5 is your C.
-5 is the y-intercept, yeah. -5 is what?
The y-intercept, the C, right?
C, correct. Yes, the -5 is the C. Because when I'll be writing y equals ax squared plus bx plus c, and I'll be comparing it with this equation which I have written, x squared minus 5, I can say that a is 1, right?
Yes.
B is 0 because there's no x value. There's nothing x here. So this
so
is
then you're
0.
just left with x squared minus 5.
Right, and c is -5.
Yes.
Right? So that is the equation. So I'm trying to, increase the things now, increase the complexity. so that we can be more simpler and we can be more confident in the questions. So
Okay.
so up and down, you understood how to do it, right?
Yes.
Now, if you want to shift it to the left or right, how
Isn't it
made
like the opposite? Like you have to subtract to go to the right?
very good. You're right, 100% right. So if you want to shift it to the left, then you have to add the number. See, shifting left
Yes.
is adding the number. You have shifted to the -5, so you have added +5.
Okay.
Now, if you want to shift it 4 units to the right,
X minus 4.
exactly. So 4 units to the right. Correct?
Correct.
Now, if I'll be writing this as if I want to shift this parabola up 6 units, what I'll be doing?
Oh, add 6.
Add 6. Okay. So it has shifted 6 units up and 4 units to the right. Correct? Now
Correct.
see the vertex. What is
4,
the
6.
vertex? What is according to the vertex?
4,
6.
6.
Right. See, 4, 6 is here.
Yes.
And do you remember the vertex form? X minus h whole squared plus
Squared
k.
plus k.
See, when you're compare x minus 4 with x minus h, doesn't that mean h is 4?
Yes.
And when we compare k with 6, doesn't that mean k is equal to 6? So h comma k is equal to 4 comma 6, and that is the coordinate of the vertex.
Yes.
Okay, so this is the vertex form, which I have written.
Okay.
Did you got this till now?
Yes, I wrote it down.
Great. Now going back to this previous x squared thing here. Okay, now let's try to understand the factored form. Now, if I want to shift this parabola down by 2 units, I know that I have to subtract subtract or add, or what?
Subtract 2.
Subtract 2. Subtract 2 in subtracting. Oh, what happened? Okay, subtract 2. So it has shifted 2 units down.
Yes.
Now it has cut the x-axis at 2 points, right? See? Negative 1.414 and positive 1.414.
Yes.
So it has cut the x-axis at 2 points. You know what? I can make one more equation, factored form of that parabola. It'll be x minus 1.414 times x plus 1.414. Maybe this seems to be a little awkward. Let's try to use one more number. Maybe let's try to use x squared minus 4. X squared minus 4. See, where is cutting the x-axis?
-2 and 2.
Correct. -2 and 2. So one more way of writing the parabola, the equation of parabola is y equals x minus 2 times x plus 2.
Okay.
Are you getting?
Yes. Because then when you factor that, you get x squared minus 4.
Exactly. When you'll be when you'll be doing FOIL to this, you'll be getting x squared minus 4 back.
Okay.
Or when you'll be factoring x squared minus 4, you'll be getting x minus 2 times x plus 2.
Yes.
So this is the factored form, right? But if the parabola is above the x-axis, will you get any x coordinate?
Then
X-intercept. It's above the x-axis. It's like about here. It's like this. It's like, you know, x squared plus 4, for example. Do you get any x-intercept?
no.
That means you'll not be having any solution for the x-intercept. You'll not be able to write the factored form in real numbers. You'll be having imaginary numbers. You'll not be having
because
the
there's no
solution.
x.
Exactly, you'll not be having the solution. So this parabola is not having any solution, any real solution, right? It'll be having imaginary solution.
Correct.
Because it is above the x-axis.
Yes.
But the parabola, which is touching the x-axis, will be having one solution because it is touching the x-axis at one point. For example, this here, it's having one solution, 0, x is 0.
Yes.
But if it
That's
is,
what we're-
yeah, if it is like x squared plus 16,
no
sorry,
solution.
negative 16. Oh, where it has been written. Minus, oh, minus 16. So, oh, okay. So here it is. So it is having two solutions, -4 and 4, right? So there's a condition that when the parabola is having a solution, is not having solution, or having two solutions or one solution. And how can that be determined, whether the parabola is having a solution or not?
You can see the x-intercept.
You can see the x, but that means you have to graph it, right?
Yes.
Without graphing, if you're having an equation y equals 2x squared minus 3x plus 4, and you want to know by this equation whether the parabola is having the two solutions, is having the one solution or no solution. That'll be done by calculating the discriminant, remember. Discriminant is equal to, we know that the general form of the equation is ax squared plus bx plus c, right?
Yes.
Discriminant can be calculated by simply b squared minus 4ac.
Oh, okay.
So can you calculate b squared minus 4ac for this equation?
Yes. 9 minus 32. Yeah. So
How much is it?
in negative 23.
Negative 23, right?
Yeah, negative 23.
Negative 23. If the discriminant is greater than 0, you'll be having two solutions.
Oh.
If the discriminant is equal to 0, then you'll be having one solution. That means it's touching the x-axis. And if the discriminant is less than 0, you'll be having no solution.
Okay.
It is not cutting the x-axis at all.
Right. Well, wouldn't you know that in the form if your y-intercept is 4, then you know it's above the x-axis.
Exactly. That is also one of the ways of understanding it. But if that is in this form, like x squared plus 4, if this form is written, then you can say that, yeah, it is not having any solution because it is above the x-axis. But if it is written like x squared minus 3x plus 4, how can you analyze at that time?
B squared minus 4ac.
Because this, yeah, that can, see, because x squared minus 3x plus 4, see, how can this thing happen here? This can, the equation can be like, the graph can be like this, like this, and then cutting it at 4.
Oh, right.
So that's why if the equation is like x squared minus plus 4, then it is clear that, yeah, it is obviously above the x-axis. But if it'll be like x squared minus 6x plus 4, then this minus 6x can make the things change. At that time, you have to calculate the discriminant, whether it is 0 or greater than 0 or less than 0. If that is greater than 0, then two solutions. It'll be cutting the x-axis at 2 points. If that is equal to 0, then it'll be cutting the x-axis at only 1 point. That means touching the x-axis. If that is less than 0, then no solution, not cutting it at all, above the x-axis.
Yes. Got it.
Is that okay till now? Okay, we'll be discussing this much for this parabola. We're having more to discuss here, but that'll be in steps, otherwise this will become more complicated. So let's go back to the question. Can you share the screen?
share screen.
Okay, so we're having a parabola here. We're having standard equation also given there. And we are told, okay, let's see what's the question. Which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation. That means you have to convert this equation into the vertex form. Simple.
Oh, okay. So what I tried to do is on A, I try to factor it, but like I only got the answer for that one, so I thought it was the correct one.
Okay, that was the factor. This is correct, but this is the factor form.
Right.
Because you're having -3 and 5 as values of x. X is -3 and x is 5. When you'll be adding 3 to it, you'll be having x plus 3 as one of the factors, and x is x minus 5 is another factor. So this is the factor form which you have understood till now.
Yeah, but it's D because
exactly, yeah.
Negative the vertex would be 1, -16.
Exactly. So vertex form is x minus h whole squared plus k, correct?
Yes.
Where h and k are the coordinates of the vertex, and you can see that the coordinates of vertex are 1, -15 or 16, like that. So it's only option D which is confirming that.
Right.
So x minus 1 whole squared plus 16, whatever that is, and that is the answer. Sorry, minus 16.
Yeah, sorry, I messed that up. Okay. Got it.
So is that clear? Vertex form.
Yes.
Factored form, vertex form, standard form. What happens when A is increased, whether A is decreased, whether A is positive, A is negative. Parabola becomes a mountain or a cup. When that becomes a mountain, when that becomes a cup. Is that it's clear till
yes.
then? Till that.
What time do we end? Just to make sure.
Yeah. 1 second. I'll be checking the clock. How much is the time right now?
For me, it's already been an hour and 10 minutes.
Hour and 10 minutes?
Mm-hmm.
Oh, okay. I was having an intention that I'll be giving 10 minutes more because we have wasted a few minutes in the start. So
Okay.
if it's 1 hour and 10 minutes, we can stop right now. No problem at all.
Okay, no, I'm fine. I was just making sure.
All right. So can we do then one more and then we can stop because, you know.
Yeah, for sure.
Okay, great. So I think you have done this correctly.
I just don't know how I got 107.14. Let's see.
See, they're telling you what's the maximum possible value for x that'll help combine weight of the truck driver and boxes below the bridge's posted weight limit. So what's that x? X is, okay, x is the number of identical boxes.
Yes.
Will that be 0.14? Like, will that be any box which is be like,
okay. They're identical boxes. So like the answer is 107.14, but you can't have a
you can't have 0.14 box.
of a box.
Exactly.
So.
That's why it'll be 107 only.
Okay.
You were right here. So what is the next one?
Okay, yeah, we only have 2 more to finish and then we're done.
Oh, okay, great.
This one for number 37, I just read it wrong. I thought it meant like what does X stand for?
Okay, it's what is the value of X in the expression? What is the value of X?
Wouldn't it be 0.02?
0.02, you're right.
Yes.
Because 2% invested, is it 0.02 or 1.02? Think about it. We have discussed this thing before, today only.
1.02.
Exactly, because you are increasing 2%. That means if you're having $100 and you're increasing 2%, you'll be multiplying 1.0 to it.
Mm-hmm.
And it'll be increasing 2% for 10 years, then 1.02 raised to the power 10.
Right.
If it's increasing by 20 years, 1.0 raised to the power 20, and so on. right? For the first year, it'll be 100 times 1.02 only for the first year.
Right, that's the equation, yes.
Okay, 38.
I think that's what messed me up because I plugged in 2.5 to the equation, but I didn't, or I plugged in 0.025, but not 1.025.
That is the problem. So
Yes.
1.025. Tasha made initial deposit 100 in this account, and the same Jessica made $100 into her account. And after 10 years, how much more money will Tasha's initial deposit have earned than Jessica's initial deposit? So it's 100 times 1.025 raised to power 10, and 100 times, what's the percentage of the what? Jessica's friend Tyshawn. Okay, Tyshawn is having 2.5%, and Jessica is having how much percent? 2%?
2%.
So 1.02 raised to power 10.
So you have to find the compound or the interest of both and then subtract.
Exactly.
I just messed up on the 1.025.
Yeah, now it's clear, isn't it?
Yes, very.
Okay, so can you quickly calculate it? 100 times
Yes, I'm doing that right
1.025 raised
now.
to power 10. Okay.
Okay, so times 100. Okay, so for Tyshawn, I got 128.008, but like 128.
Okay.
And then for
Jessica.
1.02 to the 10th. Let's see. 1.02 times 100 is 121.899.
Okay, when it'll be subtracting it, how much it'll be?
28.0. It's good. It's like 6 something. Hold on.
Okay, but the question is round your answer to the nearest cent and ignore the dollar sign.
So the nearest cent would be 6.11.
6.11. I'll be checking. Yeah, that's exactly the right answer. 6.11 is the right answer.
I got it then.
Great. So that was great, and because you have understood so many things today, and in the next paper you'll be much better, I think, isn't it?
Yes, for sure.
So should I give you one more test paper?
Yes.
That's great. So I'll be sending it on Fiverr, right?
Fiverr, yes.
Fiverr, yeah, whatever that is. So
let me just say hello. Hi there, how are you?
Hi.
Thank you so much. I'm so sorry I had to keep rescheduling, but summertime, there's so many things happening. And so I appreciate you working with us with the time.
No, I love to work with Katrina because, you know, she's understanding the things so easily and so confidently that I believe that, you know, the score will be near to the perfect score.
Oh, I'm excited. And she's excited. She just wants, somebody to give her good guidance. And it seems like, you know, I think she was really happy with your lessons. So, and I have my son too. Now he's younger, but he's 13. He's going into 8th grade.
All right.
And I just wanted to kind of test it out with her first.
Okay.
But I think I'll be able to, maybe we'll figure out something where I guess we need to just discuss the times. I couldn't figure out. I think is it very early for you over there or late?
Yeah, for example, 6:30 p.m. is okay for me, even 6 p.m. in the morning, in the evening. That's okay for me because 6 p.m. means my 4:30 a.m. in the morning.
Early. So we could even do 7:30 is fine.
Yeah, that's
that way
also
it's
fine
not
for me.
so early, 7:30 or 8:30. I think right now in the summertime, we may even do the 8:30s, right? Because I think 8:30 is good for her. And then let's continue with her. And then once I'm gonna try to get my son scheduled. And you can also, you'll be able to work with, he needs to work on math as well.
All right.
Do you want to send me something he can work on? So he's going to be taking the IC exam. Are you familiar with that one?
Yeah, ICSE, right? What?
ISEE, the IC.
ISEE. No, I have to check it out, but the thing is like
it's basically Yeah, it's math. So when she took the test, it was, what did you studied the SAT stuff also,
Yeah.
right? We
It's it's like to get into high school.
Yeah, he's
All
gonna
right.
take it in the fall, so he needs to really hit it hard. I have him reviewing 8th grade math, but basically he needs to master algebra. Let's just say that.
That's great. We'll be doing that together. No problem at all. We'll be doing that. But just schedule the things like when we'll be having the session. And in the first session, I'll be more clear about like what really, the things are and how it'll go. Because I have not seen the test paper. I'll be checking it on the internet. I'll be checking the test papers, and then we'll be discussing, the scheduling of the, algebra and everything, which is
Yes,
yeah.
perfect. And yeah, no, but I appreciate it. And then we'll keep, normally during the school year, it's very easy for me to schedule because I know the dates and times, but this time it was really hard because I was trying to figure out, we just got into summer break a week and a half ago, and then we had all these camps. And so what we'll do is we'll keep communicating. So you sent me a WhatsApp, right?
Yes, exactly. I was wondering that, like, if you could connect me on WhatsApp, that'll be great because it'll be, faster and everything.
Yes,
So
let's do that. Let's do that. That way we can schedule. It's easier for us to like just chat and say, okay, this time, that time, or
exactly. Yes,
what
that
works
is what I
best.
want. Correct. With
Okay,
Fiverr is a little
yes.
bit
So if you want
complicated.
to send me again a WhatsApp,
Okay.
and then well, did you already send it to me? Did you get my number?
I have already sent on Fiverr my number, but
Oh, okay.
yeah,
Okay.
but I can send it again if you want.
Let me give you my number so that you can connect through
Okay.
WhatsApp. It's
Okay, 1 second. Yeah, tell me.
832
832
876
876
2300.
2300.
And
Okay.
my name is Heidi,
Heidi.
Heidi.
Heidi. One of the students was Heidi for me.
Oh, okay. And so
Okay.
tell me, so are you a teacher, or why do you do this? What is your
I'm
background?
I'm actually an engineer, electronics and communication engineer. I'm working in railways. I'm a senior signaling engineer, and from 2010 I have been an engineer in a professional field. But at the same time I am teaching because I love teaching more as compared to my professional thing. So from 2011 I was a teacher in a company as an SAT instructor for
Okay.
5 years. 5 years continuously, and then I left that and I was doing myself everything. And after that I had my own tutoring center here, and I had been teaching till 12th grade students, and I
Oh,
had
excellent.
yeah,
Yeah.
yeah. And but this thing is always in my mind that I have to give something in teaching, because there's so much lagging here, when you're trying to understand the concepts. There are so many teachers who are not able to do that. I'm trying to give my best to increase the score of my students, and they feel delighted obviously when they understand the questions, when they understand how it happens, and they love maths more as compared to when they start. So
Yes.
it's my passion. Like, I love to teach, I love
I
to
can tell. I can tell it's your passion.
I love maths because it has been in my, like, maybe genetics or whatever from the start. So that's why
Okay.
I am continuing this thing. Otherwise, I'm an engineer and I'm like doing my professional things, but this thing I'm continuing continuously, from last 2000,
Yes.
from 10
Well,
years, 11 years.
wonderful. Well, thank you so much. And then you have my number. Let's chat about the next class,
Yes,
and then
exactly.
we'll get her on schedule, and then we'll get my son also scheduled.
Great. So I'll be messaging you on WhatsApp and you'll be replying, and then we'll be discussing about this
Yes.
scheduling.
Yeah.
Right.
And what is your name?
Sam, you can say Sam.
Sam.
Yeah.
Okay.
Thank you.
Thank
Thanks a
you
lot.
so much, Sam.
Thank you very much. Let's meet on next week. Thank you very much.
All
Bye-bye.
right.
Okay.
Thank you. Have a
Bye.
great evening or
You
day.
Yeah.
Bye-bye.
You also have a great evening. Bye-bye. Thanks.
Bye-bye.